Today's notes are from section 7.7, which is on exponential growth and exponential decay. Last time we talked a little bit about the equation y equals ab to the x. Today we'll be dealing with some story problems where we will need to work with that basic exponential equation y equals ab to the x. When we are working with this, a is always the initial amount. A is our starting amount. And B is what is called the growth factor. Last class we talked a little bit about if that growth factor, if B is greater than 1, that means we have exponential growth. If B is less than 1, we have exponential decay. In story problems, usually the starting amount, the A value, is usually pretty easy to get. It'll say right in the problem what the starting amount is. The growth factor sometimes is a little bit more difficult. So let's talk about how to find that growth factor. Sometimes the problem may say that something doubles. If something doubles, that means we are taking the starting amount and we are multiplying it by 2 over and over and over again. So if something doubles, we are going to make b equal to 2. I think you could probably guess that if it says that it triples, we are going to multiply the starting amount by 3 over and over again. So our b value is 3. It's possible that something could be breaking in half. In which case the b value is 1/2. So those are the easier ones to get the b value. Doubles, it's 2. Triples, it's 3. Breaks in half, it's 1/2. Sometimes it's going to grow or decay by a percentage. So if it says that it grows by 6%, it grows by 6%. Hopefully we remember how to change from a percentage to a decimal. All we're going to do is take the decimal point, which is right here, and we're just going to move it 2 places to the left. If I change 6% to a decimal, I take it, I move it 2 places, 1, 2. That's the same thing as 0.06. The problem is my b value can't be 0.06 because 0.06 is less than 1, and if it's less than 1, it's not growth. So there's something we need to do before we take that decimal point and we move it. What we're going to do, if it is growing, if it's getting bigger, we want to start with where it's at right now, and right now it's at 100%. So I'm going to take 100%, and I want to add 6% to that. So 100% plus 6% gives me 106%. So each year that goes by, or each time it grows by 6%, we are retaining the 100% that it was at, plus we're adding 6% onto that. So we're getting back 106% of what it was. And then we need to change it to a decimal. So my decimal point's here, now I move it 2 places and it goes right there. So in this case, my b value would be 1.06. It might say it decreases by 6%. Decreases by 6%. Again, we don't want to make b 0.06. That would just mean it keeps 6% of its value. But right now it's at 100%, so we're going to take 100%, and we want to subtract 6% from that. %, minus 6% gives me 94%. And then I take the decimal point and I move it 2 places. 1, 2 gives me b is 0.94. Before we jump into the story problems, I want you to decide if the story problem says this over here, what is the b value equal to over here? So the first one, let's suppose it says that it multiplies by a factor of 4. If it says it increases by 14%, or if it says it decreases by 2.8%. So for each of those circumstances, I want you to decide what you think the b value is going to be. Write those down, and then in a minute we'll talk about it. If it multiplies by a factor of 4, as you would probably guess, b is equal to 4. We're multiplying by 4 over and over again. If it says increases by 14%, we start with 100%, we add on 14%, giving me 114%. And then we move the decimal point 2 places. 1, 2, it's right there, 1.14. B should be 1.14 in that case. Decreases by 2.8%. I've got 100% minus 2.8%. Giving me 97.2%. And then I move the decimal point 2 places to the left to make it a decimal instead of a percentage. Gives me 0.972 for b value. Let's go ahead and start taking a look at what these story problems will look like. Example 1 says that we have a population of bacteria, and it starts at 22 and then triples every hour. It's kind of gross. Population of bacteria starts at 22, triples every hour. We need to find how many bacteria there are after 4.5 hours. You should be taking notes. You don't necessarily need to write down every word. The minimum I would put in my notes to have good notes here is starts at 22, triples every hour. How many after 4.5 hours? That's fine. That's enough of a problem to go in your notes. But if you just write the answers down and don't put any of the problems in there, that's not going to help you out. So the stuff I have highlighted is the minimum you should put in your notes there. We have a population of bacteria. It starts at 22. It is tripling every hour. We are asked how many bacteria there are after 4.5 hours. And then that last sentence is just telling us how to round our answer. We need to round to the nearest whole number, the nearest bacteria. Because I am tripling, I'm multiplying by 3 over and over and over again. That's why I have an exponential equation. An exponential equation, the general form is y equals ab to the x. I would write that equation down first. Think about what our a value should be. Remember, our a value is our starting amount. So the amount of bacteria we start with here pretty clearly is 22. And then our b value is the growth factor. The growth factor, if it says that it triples, should be 3. So our equation here, that's a times sign. Our equation is y equals 22 times 3 to the x. We're looking for the final amount of bacteria, which is our y value. X is the number of times that it multiplies by 3. So if it multiplies by 3 one time, it would be 22 times 3. And 2 times, we would put 2 in there. 22 times 3 times 3, or 3 to the second, and so on. If it triples every hour, after 4.5 hours, it will have tripled 4.5 times. So I want 22 times 3 to the 4.5 power. And now it's a calculator problem. 22 times 3 to the 4.5 power. Gives me this. It tells us to round to the nearest whole number, the nearest bacterium. I've got 0.51, which is going to bump it up to 3,087 bacteria. So notice we started at 22. It grew to over 3,000 after 4.5 hours. So exponential equations, remember, they get really big or really small if we have decay pretty quickly. They grow much faster than linear equations. Example 2. Example 2 says we have 30 frogs that are introduced to a swamp. I don't know why I put forest here. The number of frogs in the swamp doubles every year. We are asked how many frogs would be in the swamp after 8 years. So again, the minimum that should be going in your notes, I have 30 frogs. It doubles every year. And we are looking for how many after 8 years. So we are starting with 30. It doubles every year. We want to know how many exist after 8 years. Again, because we're doubling, we're multiplying by the same thing over and over and over again. That is why we use an exponential equation, y equals a times b to the x. A is our starting amount, which hopefully we can recognize as 30. B is the growth factor. The problem says that the number of frogs in the swamp doubles every year. If it is doubling, our growth factor is 2. That is the exponential equation that we are looking for, y equals 30 times 2 to the x. It doubles every year, so after 8 years, we would put 8 in for our x, and we are trying to solve for y. We want to multiply by 2 8 times. So 30 times 2 to the 8th gives me a lot of frogs. 7,680 frogs. A couple more problems here. Example 3 says we have a town. Its population starts with 32,000 people. That sounds important. That population grows by 2% every year. We are looking for the population after 10 years. So we have 32,000 people. Every year that population is going to grow by 2%. We are looking for the town's population after 10 years. And we are asked to round our answer to the nearest person. So y equals a times b to the x. The initial amount of people we have is 32,000. That goes in for a. B, we practiced earlier how to come up with B if it grows by a percentage or decreases by a percentage. So if it grows by 2%, we're going to start with 100% and add 2% to that. We are adding because it's increasing, it's growing, to give me 102%. We don't want to put 102 in. We need to change that percentage to a decimal. The decimal point right now is right there, and we're going to move it 2 places to the left. So our B value should be 1.02. There's our formula. Y equals 32,000 times 1.02 to the x. It grows by 2% every year, so after 10 years, it will have grown 10 times. So I want 32,000 times 1.02 to the 10th. 32,000 times 1.02 to the, I probably should have mentioned it before, the to the button, remember it's right above divided by, it's right here. 10th. Round to the nearest person, 0.82 is going to round up, so I have 39,008 people. Last one, example 4. You buy a car, you pay $22,000 for that car. That's our starting amount. The car loses 11% of its value every year. What is the car worth after 7 years? We're going to round our answer to the nearest dollar. A car gets purchased for $22,000. That is going to decrease by 11% every year. We need to know the value of the car after 7 years, rounded to the nearest dollar. Write your formula down first. Y equals A times B to the X. Starting amount is the A value, which in this case is $22,000. B is the growth factor. Loses 11% of its value every year. It starts with 100% and it's losing 11%. 100 minus 11 is 89. We should be keeping 89% of its value every year. Decimal points right there. Move it 2 places to the left. We get 0.89. And then X is 7. It loses 11% every year for 7 years. So it will have kept 89% of its value 7 times. And then again, it's a calculator problem from there. 22,000 times 0.89 to the 7th to the nearest dollar. It is now worth $9,731. That is the notes from section 7.7.